Our lives depend on a world we can't see. Think about your week so far. Have you watched TV, used GPS, checked the weather, or even ate a meal? These many things that enable our daily lives rely either directly or indirectly on satellites. And while we often take for granted the services that satellites provide us, the satellites themselves deserve our attention as they are leaving a lasting mark on the space they occupy. People around the world rely on satellite infrastructure every day for information, entertainment, and to communicate. There's agricultural and environmental monitoring, internet connectivity, navigation. Satellites even play a role in the operation of our financial and energy markets. But these satellites that we rely on day in and day out have a finite life. They might run out of propellant, they could malfunction, or they may just naturally reach the end of their mission life. At this point, these satellites effectively become space junk, cluttering the orbital environment. So imagine you're driving down the highway on a beautiful sunny day out running errands. You've got your music cranked, your windows rolled down with the cool breeze blowing through your hair. Feels nice, right? Everything is going smoothly until suddenly your car stutters and stalls right in the middle of the highway. So now you have no choice but to abandon your car where it is on the highway. Maybe you were lucky enough to be able to move it out of the way and into a shoulder lane so that it's out of the way of other traffic. A couple of hours ago, your car was a useful machine that you relied on in your everyday life. Now, it's a useless hunk of metal taking up space in a valuable transportation network. And imagine international roadways all cluttered with broken down vehicles that are just getting in the way of other traffic. And imagine the debris that would be strewn everywhere if a collision actually happened. Thousands of smaller pieces of debris becoming new obstacles. This is the paradigm of the satellite industry. Satellites that are no longer working are often left to deorbit over many, many years, or only moved out of the way as a temporary solution. And there are no international laws in space to enforce us to clean up after ourselves. So the world's first satellite, Sputnik 1, was launched in 1957. And in that year, there were only a total of 3 launch attempts. Decades later, and dozens of countries from all around the world have launched thousands of more satellites into orbit. And the frequency of launches is only going to increase in the future, especially if you consider things like the possibility of 900 plus satellite constellations being launched. Now, we send satellites to different orbits depending on what they're needed for. One of the most common places we send satellites is the low Earth orbit, possibly to image the surface of Earth at up to about 2,000 kilometers altitude. Satellites there are naturally buffeted by Earth's atmosphere, so their orbits naturally decay, and they'll eventually burn up, probably within a couple of decades. Another common place we send satellites is the geostationary orbit at about 35,000 kilometers altitude. Satellites there remain in the same place above Earth as the Earth rotates, which enables things like communications or television broadcasts, for example. Satellites in high orbits like these could remain there for centuries. And then there's the orbit coined the graveyard, the ominous junk or disposal orbits, where some satellites are intentionally placed at the end of their life so that they're out of the way of common operational orbits. Of the nearly 7,000 satellites launched since the late 1950s, only about 1 in 7 is currently operational. And in addition to the satellites that are no longer working, there's also hundreds of thousands of marble-sized debris and millions of paint chip-sized debris that are also orbiting around the Earth. Space debris is a major risk to space missions, but also to the satellites that we rely on each and every day. Now, because space debris and junk has become increasingly worrisome, there have been some national and international efforts to develop technical standards to help us limit the generation of additional debris. So, for example, there are recommendations for those low Earth orbiting spacecraft to be made to deorbit in under 25 years. But that's still a really long time, especially if a satellite hasn't been working for years. There's also mandates for those dead geostationary spacecraft to be moved into a graveyard orbit. But neither of these guidelines is binding under international law, and the understanding is that they will be implemented through national mechanisms. These guidelines are also not long-term, they're not proactive, nor do they address the debris that's already up there. They're only in place to limit the future creation of debris. Space junk is no one's responsibility. Now, Mount Everest is actually an interesting comparison of a new approach to how we interact with our environments, as it's often given the dubious honor of being the world's highest garbage dump. Decades after the first conquest of the world's highest peak, tons of rubbish left behind by climbers has started to raise concern. And you may have read in the news that there's speculation that Nepal will crack down on mountaineers with stricter enforcement of penalties and legal obligations. The goal, of course, is to persuade climbers to clean up after themselves. So maybe local not-for-profits will pay climbers who bring down extra waste, or expeditions might organize voluntary cleanup trips. And yet still, many climbers feel that independent groups should police themselves. There's no simple or easy answer, and even well-intentioned efforts at conservation often run into problems. But that doesn't mean we shouldn't do everything in our power to protect the environments that we rely and depend on. And like Everest, the remote location and inadequate infrastructure of the orbital environment make waste disposal a challenging problem. But we simply cannot reach new heights and create an even higher garbage dump, one that's out of this world. The reality of space is that if a component on a satellite breaks down, there really are limited opportunities for repairs and only at great cost. But what if we were smarter about how we design satellites? What if all satellites, regardless of what country they're built in, had to be standardized in some way for recycling, servicing, or active deorbiting? What if there actually were international laws with teeth that enforced end-of-life disposal of satellites instead of moving them out of the way as a temporary solution? Or maybe satellite manufacturers need to be charged a deposit to even launch a satellite into orbit, and that deposit would only be returned if the satellite was disposed of properly or if they cleaned up some quota of debris. Or maybe a satellite needs to have technology on board to help accelerate deorbit. There are some encouraging signs. The UK's Tech Demosat-1, launched in 2014, for example, was designed for end-of-life disposal via a small drag sail. This works for this satellite because it's small, but satellites that are higher or in larger orbits or are larger altogether, like the size of school buses, will require other disposal options. So maybe you get into things like high-powered lasers or tugging using nets or tethers, as crazy as those sound in the short term. And then one really cool possibility is the idea of orbital tow trucks or space mechanics. Imagine if a robotic arm on some sort of space tow truck could fix the broken components on a satellite, making them usable again. Or what if that very same robotic arm could refuel the propellant tank on a spacecraft that relies on chemical propulsion, just like you or I would refuel the fuel tanks on our cars? Robotic repair and maintenance could extend the lives of hundreds of satellites orbiting around the Earth. Whatever the disposal or cleanup options we come up with, it's clearly not just a technical problem. There's also complex space laws and politics that we have to sort out. Simply put, we haven't found a way to use space sustainably yet. Exploring, innovating to change the way we live and work are what we as humans do. And in space exploration, we're literally moving beyond the boundaries of Earth. But as we push thresholds in the name of learning and innovation, we must remember that accountability for our environments never goes away. There is without doubt congestion in the low Earth and geostationary orbits, and we cannot keep launching new satellites to replace the ones that have broken down without doing something about them first, just like we would never leave a broken down car in the middle of the highway. Next time you use your phone, check the weather, or use your GPS, think about the satellite technologies that makes those activities possible. But also think about the very impact that the satellites have on the environment surrounding Earth and help spread the message that together we must reduce our impact. Earth's orbit is breathtakingly beautiful and our gateway to exploration. It's up to us to keep it that way. Thank you.